Imagine this. Almost 50 years ago, there was no internet, no smartphones, no GPS, no artificial intelligence. And yet, during that era, humans built a machine that is still alive today, still working, still communicating with Earth, and still exploring regions of space where no human has ever been. Today, this machine is more than 25 billion kilometers away from Earth, so far away that a single radio signal takes over 23 hours to reach us. That means if NASA sends a message right now, Voyager won't receive it until tomorrow, and its reply won't arrive until the next day. But that's not even the most incredible part. The most incredible part is that it was only designed to operate for about 5 years. And yet, almost half a century later, it is still traveling through the silent darkness of space. This is Voyager 1, the most distant human-made object in history. An opportunity that comes once every 176 years. Back in the 1960s, scientists were studying the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. Then they discovered something extraordinary. The positions of these four giant planets were about to align in a way that happens only once every 176 years. This alignment created a rare opportunity. A spacecraft could travel from one planet to another using the gravity of each planet as a slingshot. This technique is called gravity assist. Imagine running alongside a moving train. The train gives you a push, and suddenly you're moving much faster than before. That's essentially what gravity assist does. A spacecraft approaches a planet, steals a tiny amount of the planet's orbital energy, and gains tremendous speed. Without gravity assist, the Voyager mission would have been impossible. NASA knew they could not miss this opportunity. If they failed, the next chance wouldn't come until the 22nd century. Launch Day, September 5th, 1977, Cape Canaveral, Florida. A massive Titan III rocket stood on the launch pad. Sitting on top was Voyager 1. Interestingly, Voyager 2 was actually launched first, but Voyager 1 was given a faster trajectory. That's why it reached Jupiter and Saturn earlier. The rocket engines ignited. A giant cloud of fire erupted beneath the vehicle, and Voyager 1 began its historic journey. At that moment, nobody imagined this spacecraft would still be functioning in 2026. What exactly is Voyager 1? Voyager 1 is not just a spacecraft. It's a flying scientific laboratory. At launch, it weighed about 825 kilograms, roughly the weight of a small car. Its most recognizable feature is its enormous high-gain antenna, a dish nearly 3.7 meters wide. This antenna is Voyager's voice, its ears, its lifeline to Earth. Attached to the spacecraft are numerous scientific instruments: cameras, cosmic ray detectors, plasma sensors, magnetic field instruments, radio receivers. Each instrument was carefully chosen. Every gram mattered, because once Voyager left Earth, there would be no repairs, no upgrades, no second chances. How powerful is its computer? Now prepare yourself for something shocking. The smartphone in your pocket today is millions of times more powerful than Voyager's computer. Voyager's memory was so limited that a single modern photograph could exceed its entire onboard memory capacity. The spacecraft contains three main computer systems. One processes commands from Earth, one manages scientific data, and one controls orientation and navigation. Its memory is measured in kilobytes, not megabytes, not gigabytes, kilobytes. Yet despite its limitations, these computers have continued operating for nearly 50 years, surviving radiation, extreme temperatures, and the unforgiving environment of deep space. Where does its power come from? Now comes one of the most fascinating questions. How does Voyager still have electricity? Does it use solar panels? No, because sunlight becomes extremely weak in the outer solar system. Instead, NASA equipped Voyager with a special power source called an RTG, a radioisotope thermoelectric generator. Inside it is a radioactive material known as plutonium-238. As the plutonium naturally decays, it produces heat. Special thermoelectric devices convert that heat directly into electricity. In other words, Voyager 1 runs on a tiny nuclear power plant. At launch, it generated about 470 watts of power. Today, that output has declined significantly, which is why NASA has gradually shut down non-essential systems, trying to keep the spacecraft alive for as long as possible. How does it know where to go? Voyager has no GPS, so how does it navigate? The answer lies in its star trackers. These instruments identify stars and determine the spacecraft's orientation. It also uses gyroscopes, which continuously measure its position in space. If Voyager drifts even slightly off course, tiny thrusters fire bursts of gas, rotating the spacecraft back into alignment. This is crucial, because if the antenna points away from Earth by even a few degrees, communication could be lost. Jupiter changes everything. March 1979, Voyager 1 arrived at Jupiter, and it immediately began rewriting textbooks. The spacecraft captured stunning images of Jupiter's atmosphere, its colorful cloud bands, its giant storms, and the famous Great Red Spot. But the greatest discovery came from one of Jupiter's moons, Io. Scientists noticed enormous plumes rising from the surface. At first, they suspected an imaging error, but it wasn't. These were volcanic eruptions, active volcanoes. For the first time in history, humanity had discovered active volcanism beyond Earth. The scientific world was stunned. How did it send pictures back to Earth? Think about this. It's 1979. There is no internet, no wireless networks, no data centers. Yet Voyager is sending images across billions of kilometers. How? The spacecraft converts images into digital data, then transforms that data into radio signals, and beams those signals toward Earth. After traveling through space for billions of kilometers, the signal becomes incredibly weak, far weaker than the signal from a cell phone. Yet NASA can still detect it, thanks to the Deep Space Network, a system of giant radio antennas located in California, Spain, and Australia. These antennas are among the most sensitive listening devices ever built. They can hear whispers from the edge of the solar system. Saturn and Titan. In 1980, Voyager 1 reached Saturn. The spacecraft sent back breathtaking images of Saturn's rings, images unlike anything humanity had seen before. But scientists were especially interested in one destination, Titan, Saturn's largest moon. Titan possesses a thick atmosphere, something extremely rare among moons. NASA decided Voyager must fly close to Titan. The data collected was invaluable, but the decision came with a cost. That maneuver permanently changed Voyager's trajectory. As a result, Voyager 1 would never visit Uranus or Neptune. Its path toward interstellar space had begun. The Golden Record. Hidden aboard Voyager is one of the most fascinating objects humanity has ever launched. The Golden Record, a gold-plated phonograph record, designed as a message to any future civilization that might find the spacecraft. The record contains greetings in 55 languages, music from around the world, animal sounds, ocean waves, human laughter, and more than 100 images of Earth. Voyager is not just a spacecraft, it is a time capsule of humanity. The pale blue dot. In 1990, Voyager was billions of kilometers away. At that point, astronomer Carl Sagan made a remarkable request. He asked NASA to turn Voyager around one final time and photograph Earth. The spacecraft obeyed. The resulting image became one of the most famous photographs in history. Earth appeared as nothing more than a tiny blue speck, suspended in a beam of sunlight. The image became known as the pale blue dot, a reminder that every human being, every civilization, every war, every dream, and every achievement exists on that tiny point of light. Leaving the solar system, August 25th, 2012, a historic moment. Voyager 1 crossed the heliopause, the boundary where the sun's influence begins to fade. For the first time in history, a human-made object entered interstellar space, the space between the stars. Voyager was no longer exploring planets. It was exploring the unknown. Where is Voyager today? Today, Voyager 1 is more than 25 billion kilometers away from Earth. It travels at roughly 17 kilometers every second. Its signals take over 23 hours to reach Earth. And despite everything, it still sends scientific data, still teaches us about the environment beyond our solar system, still represents humanity's endless curiosity. One day, Voyager's remaining power will finally run out. Its instruments will go silent. Its voice will disappear forever. But Voyager itself will continue its journey. For thousands, millions, perhaps even billions of years, drifting through the darkness between the stars, carrying a message from humanity. And perhaps someday, a distant civilization will discover this lonely spacecraft and learn that once, on a tiny pale blue dot, there lived a species called humans who dared to reach for the stars.